Here we're going to be solving for x. You'll notice a couple of Greek letters here. Let's take a look at a list of Greek letters. In the first column, you've got the uppercase and the lowercase, and this is called alpha. The closest equivalent is, of course, A, and then this is how it's pronounced. So if you're curious, there they are. The formula that we're looking at has the lowercase mu. Uppercase mu looks just like our M. Lowercase mu kind of looks like a U with a tail on the front. It also uses the Greek letter sigma. Uppercase sigma and lowercase sigma look very different, but it's most like our S. So maybe you recognize some of these from sorority and fraternity type things, from religious studies, all sorts of things. Very interesting. Okay, so back to the problem. What you need to keep in mind is even though it's a Greek letter, it's treated just like a variable as far as solving for x. And you can also think of mu and sigma and z as numbers. How would you approach it? So just like the problem prior to this one, if you've got this fraction, it's best to get rid of the fraction by multiplying by the denominator. If you have more than one fraction, you would want to multiply by the least common multiple of those denominators. Okay, so that will clear the fraction. On the left, sigma z, what did we do to bring it to that side? What did we do to both sides? We multiplied, so you're going to attach those to each other like you would a coefficient and a variable. Last step, we have this mu on the left. It's being subtracted, so in order to cancel it out, we need to add mu to both sides. And finally, since we were solving for x, it's best to write it as x equals everything else. If you have sigma and z reversed so that it says z sigma, that's okay. And also if you have mu plus sigma z, that's all right too, because both multiplication and addition are commutative, meaning that the order does not matter.